All right, so in the first part of this lecture, I talked about object-oriented design. We kind of talked about some conceptual ideas regarding object-oriented design, why we're putting certain methods and properties or attributes in various classes. We talked about building these classes. I related this to our actual already built application just to illustrate a couple of those points, and also the existing MySQL database for that same application. And so I use those things to illustrate kind of why we put certain things in certain classes, and the concept of inherited parts versus incremental parts, and this idea in general that a lot of object-oriented design is determining which things are similar enough to go together and which things are different enough to be incremental. One other thing that I wanted to quickly point out is this base class here. This is a special type of class in this situation, and the reason why is because these classes are fundamentally, right, so first of all, remember, these are entity classes. These entity classes can be instantiated. We can create instances of these classes. So user, hotel, favor, right? We can create an instance of a hotel, like the Clarkson Inn. We can create an instance of a user, right? And that user can sign in. Base class is kind of different though, because we can't create an instance of a base class. What is that? What would that be? Well, it's really nothing. It's really just an abstract idea of this general thing that is the parent class to all of these child classes. And so this sort of class we call a abstract class. And in Python, this isn't super important. In some programming languages, you may hear this concept, right, of an abstract class. And why is it an abstract class? Well, because this is an abstract idea. It's not a concrete thing. It doesn't relate to something in the real world or something that at least is like an idea in our application. It's really just a place where other classes inherit from. Okay, so this idea is of this abstract class is important to remember. All right, so speaking of abstract versus concrete, we're going to take this kind of general abstract idea of our class diagram, and we're going to actually implement this and build a real. I'm going to build a user class and base class just so we can kind of see how this should be set up. Okay. All right, so really what we're trying to do here is I'm going to start with a user class because I think that that's a little bit more, because it is concrete, right? And so I'll start talking about that user class. All right, so class definition. So first of all, let me save this. So I'm going to save this as, whoa, I'm in way the wrong directory here. I'm going to save this in my Google Drive so that other people can have access to it. Of course, Google Drive doesn't come up here. So I have to go to here, Google Drive. Okay, and so I'm going to call this class file, I'm just going to call it user class, let's just call it user.py. So user.py, I'm going to save it here, and so that way we get the syntax for Python, syntax highlighting. All right, so I'm going to call this, I'm going to just kind of build a normal class definition. So just as a refresher, right? So we say class user. And then remember, in Python, you know, normally if we're just building a class definition, we do this, right? But here, we want to show that the user class is actually a child class of the base object. And so I'm actually going to change the name of this so that I'm consistent with my other material to base object, like that. So I'm going to say user inherits from base object. Okay, so the first definition here is going to be our constructor. And so remember how we build a constructor. It's def, so just a normal, like a function definition, right? But it's underscore underscore, 2 underscores, init underscore underscore. And it takes, in this case, one argument, well, not really an argument, it takes self, where arguments normally go. And this is because it's a method. So remember, all methods that have to act on data have to take self as an argument in Python. This is kind of how it is, okay? So remember, I don't usually consider this an argument to the method. This is just usually, you know, again, the object passes itself to itself when it calls methods, just so that it can act on its own data. All right, I'm going to create a variable here. So I'm going to talk about my variables. Table name, primary key name. So I'm going to say tn equals, and I have to give it a table name. At this point, I'm not exactly sure what that table name will be, but let's just call it user table. And remember, anytime we go to use the table name in our class definition or anywhere in our application, when we go to use a class table name for the user class, we'll just use the property as it's defined here. So if we ever need to change that table name, say it changes in the database or whatever, right, we can just change it here, change the string. Okay, PK, so here's our primary key. And remember, this is our primary key. It's not the primary key for a particular user, it's the primary key name. It's the field name for a primary key. And in this case, it's going to be ID. All right, now I'm going to call a method. And even though we don't have this method yet, I'm going to call a method called setupObject. And setupObject is going to take a table name and a primary key. Now this is very important. This self.setupObject, right, we haven't actually defined this yet. This method is going to actually call from this class, it's going to reach back here, and it's going to call the method here, okay? Because this method, this setupObject, even though it's not defined here, it will be called, and actually I guess I might as well define it now, setupObject. And what this method is going to do is it's going to do all of the normal things that have to happen every time we instantiate any of these. And so it's going to be a general method that will handle the creation of an object. Okay? All right. So before we get too carried away here, let's go and actually start creating this base object because we don't have it right now. All right. So I'm going to create a new file, and I'm going to define the base object here. I'm going to say class. Remember? So let's save it first. So class. This is going to be called. I'm going to call it base object.py, and it's going to be called class base object. And what does it inherit from? Remember, it doesn't inherit from anything. This is the base layer of our entire application object model, so it's not going to inherit from anything. So we'll just do this, and at this point we have a couple of things that we need to put in here. So I'm gonna, you know, there's a lot of things that go in our base object for attributes. So like the database query, a database connection string, like what your database server name is, what the port of the database is, the username, all that stuff will eventually go here. But at this point, I'm just going to put a couple of things that we need internally. Okay, and so I'm going to define them, but I'm going to define them inside of our setup object method. Okay, so setup objects, it's going to take an argument self, it's going to take an argument table name, and it's going to take an argument primary key. And so why these arguments? Why did I pick these arguments? Well, remember, the only thing that really separates a user from a base object is the table name and the primary key field name. The fields are different, but the way, so, and I could have taken all those fields, I could have taken a list of values for those fields. The problem is that that list of values, right, it already exists in the database, right? Because in order to build a MySQL table, we have to define those fields, right? So we have to define that schema in the structure. Because we have to define that schema in the structure, right here, right, we don't want to have to define all those fields here plus here. So actually what I'm going to do to simplify our application is I'm going to get the fields, these fields, email, fname, lname. I'm actually going to populate these from the database, right? And that's going to save us like having to, do this kind of redundant process of, okay, go in here, add all the fields, then go over here to our class definition and add all the fields here. Right? We don't want to have to do that twice, and so I'm going to avoid doing that by defining these only in the database and then going and getting them from the database when we instantiate the object. Okay, so actually it turns out, even though these are here, I'm going to just make it clear that these are actually going to be defined in the database. So I'll kind of gray them out here so that we remember that even though these are methods, these are these are properties, these are kind of defined at runtime, right? Whereas these things, we need to define these. We can't, we won't know where to get them from the database unless we define them. So the really important things are the table name and the primary key name. And we'll talk about why that primary key name is important a little bit later on. All right, so setup object. What does setup object have to do? Well, it has to do a couple of things. Basically, it has to kind of initialize a couple of values and kind of properties. So the first property is self.tn. So remember, self.tablename is going to be the property which stores the table name. So we're taking the table name that comes in as the argument when we instantiate this class, and or when we instantiate this class, and we are storing it internally in the class. All right, next one, self.pk equals pk. All right. We need a place to store the actual data as well. And so in our object model, what I'm going to do is make it so that each one of these classes has a property called data. And data is going to be a list, okay? And actually it's going to be a list of dictionaries. And so you guys should be familiar with this idea that, right, it's very common to represent a table with a list of dictionaries. And by doing that, we can populate data from the database, and an individual user class, an instance of a user class, is actually going to be a user group. It's actually going to represent a list of users, not just one single user. And this is just because a lot of the time in an application, you want to actually carry around a collection of users, not just a single user. And so, for example, right, if I click this page, user page, right, I have actually a collection of users here. And this is actually pretty common. It's pretty common to do this. So because of that, I want our application to be able to handle a collection of users. And so the user list is going to be defined as self.data. And I'm going to define this as just a blank list. There's also one more thing that I'm going to define here, and that's going to be self.errors. And this is going to be a list essentially of errors that have to do with fields. And so like if I go into a user and I click save changes, right, there's a number of errors here, right? If I go to save changes, right, there's an error with the email. It says email address must be provided. First name, please enter a first name. Last name, please enter a last name, right? This is a list of errors, right? There's multiple errors, kind of a list of strings. They relate to a single field, right? This list of errors, I'm actually going to define here. I'm going to put this as a list here. And those are going to be specific to a particular object. So I'm going to, but the fact that it's a list, that idea, right, the error messages themselves are going to be different, obviously, between a hotel and a favor and a user. But this idea that it's going to be represented as a list, this is something that we can define in the base object. Because even though the errors themselves are going to be different, the data structure that stores those errors, it's all the same, right? So that's why I can define it in the base object. All right. Setup object, so that's fairly well defined. So I'm going to save that. Let's see. User, so in the user class here, I'm going to save this. And notice now what happens. We create a user instance. It sets up the object. It knows the table name. It knows the ID. And it stores those things with that particular object. All right, and so I'm going to do a couple of unit tests here just to kind of demonstrate this. All right, let's see. All right. So let's create a unit test for this application. So I'm going to create a new script, and I'm going to save it as unit tests.py. And this is where I can actually check my object model and you know, do kind of sample code with my object model just to make sure it works. So the first thing that I'm going to do is I'm going to instantiate a user object. So I'm going to say u equals user, and I'm going to, that's all I'm going to do. Okay. And so actually, you know, the first thing here is how do we know where to get user? So the point is that we actually need to import these. So I'm going to do that. Okay. And so from base object, import base object, from user, import user. Right, so we're gonna need the code from both of our helper kind of class definitions here. In addition to that, I'm also going to add in the user class, since the user class inherits from the base object, we also need to put that same piece of code. We don't need this, but we need this. Okay, so from base object, import base object, and that's just so that when we inherit from the base object, this will work. All right, so I know there's kind of a lot of abstract, weird stuff here going on. So let's just try this, and I'll start a command prompt here. So you can see I'm in the folder, and I'm going to say Python, and I'm going to run my unit test script. So Python unit tests.py, and it runs. And so, of course, you know, instantiating a user, we don't actually do anything with this user, but we instantiate the user, and it seems to work. Okay, so let's build at least one function here that can kind of like work with our application. So how do we add fields to a user? And so again, you know, there's lots of different ways you can build this application and build this framework. But what I like to do is to set up something a little bit like this, right? And so we want a model that looks like this. So what we want to be able to do is we want to be able to create a new user instance, create a new row, so essentially create a new record in the database, right? And remember, this is, at this point, it's only in memory. Enter in the fields that we want. We want to be able to append that data to our object, to our user object, and then we want to say u.insert, and we want to take that object and then insert it into the table. Now, I'm not going to write the database code today, but I want to get this part working. And so let's also do u.verify. Verify new, because we need that function as well. Right, so the kind of workflow will look a little like this. If you want to create a new object and put it in your database using our framework, you create a new object, a user object. You'll create a new row for the user. You'll get a couple of the fields. You'll append that row to the data object. You'll verify it, and then you'll insert it to the database. And so we want to get it so that we can run this unit test with and add this user to the database without having to, right? So without having to actually write the database code every single time. So that's kind of our goal. So I'm going to save this. And so what are the functions we need? Well, we can actually see here that u.data.append, this actually turns out that this is using just the normal list append function. So that's fine. So actually it turns out that if we wanted to run this piece of code here, we can run it and it actually works, right? Because this is saying, okay, u.data, which we defined here, self.data, right? Append this new row. And so let's kind of verify that it worked. So what I'm going to do is in our base object, I'm going to create a, let's see, in our base object, I'm going to create a function, and it's going to create a data table. And this will allow us to view the current contents of the object. And so it's going to be get data table. Oops. So I already wrote this, as you can see. Let's just try it out. Oh, we have to call the function first, of course. u.get data table. Okay, there we go. So we can actually see the object now. This is a little bit kind of more reassuring that it's actually working. I want to point out, right, we can actually add multiple users to this same object, right? So if I add another user here, like this, and I run my unit test again, you can actually see now that I've added that code, right, it lists the user. Now, the point here is, so remember, this user has not actually been stored to the database. We have no database connectivity yet. We haven't built that in. We have the standard way that this works set up. We have it storing data to memory. So I'm not going to go any further than this into building the application framework. I just want to kind of go back and review a couple of kind of things that we talked about during the lecture, just so that we can kind of remember how object-oriented programming works and remember how instantiation works. Okay, so I have a base object here. This is defined. I defined basically two methods. One is called setUpObject. The other is called getDataTable, right? And again, this code here, I already pre-wrote this. All it does is essentially go through this list of dictionaries and print it in a nice formatted way for the terminal. We also have a user class. So the things that are in this user class, notice there's actually not that much in this user class. The only real thing that we care about is the user table, the table name, and the primary key, right? And that's really because if we go back to our object model, the only things that are really different here, the incremental things, are going to be what the table name is and what the primary key name is. Now, it is a little bit confusing because these look like they're defined here. They look like they're inherited, but they're actually, the values are, so the field names are inherited. So user, hotel, favor, they all have table names, they all have primary keys. The values of those table names and the values of those primary keys are defined when we instantiate a user. And so you can see here, this user object, when a user object is created, right, it calls self.setUpObject. So this method call, self.setUpObject, this is making a call back to the parent class, right? Because setUpObject is not defined in this class. SetUpObject is defined in the base object. And so this is where we're really kind of leveraging that inheritance. If we built another class, so say hotel, what would that class look like, right? That class would essentially be the same, but the table name and the primary key potentially could be different. Okay? So we've got this code here, right? This is the inherited code, and we've got the user code, which this is only the things that are different. And again, the things that are different are just the table name and the primary key. So we have these two files. These are our class definitions. And here's our main kind of testing grounds for our application. We called it unittest.py. And in this, I import the user object, I import the base object. If you were going to have another object, like a hotel object, you would have to import that too. You'd say from hotel, import hotel, right? I've instantiated our user object, so I'm using the object, the user class definition to create an instance of a user. I'm creating a new row. Now remember, this has nothing really to do with our object-oriented design. This is really just a dictionary, right? I'm taking that dictionary, I'm appending it to our user object. I'm creating a new user dictionary, and then I'm appending that as well to our user object. And then I'm just printing the contents of our data table, right? And remember, this data table is in memory. It's not in the database yet, right? So it hasn't been written to disk. It's just in memory. Okay. So that's it. All right, so again, right, remember we have 3 files here. If we were going to build an additional class in our application, we'd copy this user class, we'd change the names here, and then we'd write the unit test for it. All right, so that's our kind of start of our object-oriented framework. Next week, we're going to start to add database functionality, and we're going to start to add the insert and update functionality so that we can actually call u.insert, u.update, and make changes to our data model inside of our database. The point here, the goal, is to get this to the point where we can just call individual functions, and we don't have to worry so much about all the inner workings here. That's kind of the goal, and that's kind of where we're going to go to next week. And then we can start to use our framework in lots of contexts. So we can use our framework. The goal is we'll be able to use our framework for a command line application, but also potentially a Flask application in the future. And so this will really streamline the design process by having this framework. All right, so the very last thing that I'm going to do is I'm going to write the verification function. And so I actually have this written out just so that for the sake of time, I'm just going to put it here and then explain it. So remember, our verification function is something that we want to update, or we want to define inside of the user class, because the way that it behaves is going to be specific to a user. So I'm going to call this verify new. All right, so a couple of things about this function. So I'm just going to kind of describe it here. Whoops. All right, so inside of verify new, create a new function definition because it's different. The way we verify a new user is going to be different than the way we verify a hotel, say. Self.errors. I'm going to clear our error buffer, our error list. Now remember, self.errors, it's not defined here. It's actually defined in the base object, self.errors, right? But that's okay. We can still clear it inside of this object. So I'm going to say self.errors clear because we're rechecking all the errors. So if we had any errors left over from verifying errors before, we want to make sure those are all eliminated. So I'm going to say if self.data n fname equals blank. So what am I doing here? So n is going to be a variable which allows us to specify a particular user. So you remember when I added 2 users, if I add 2 users to the object, it's possible that I want to verify only the first one or maybe only the second one. And n, passing n, allows us an index so that we can specify which one to check. That's all. If self.data n, so the user number, right, so this is the data table. So this is, remember, think about the data property as being a table within the user object. Self.data n fname equals blank. We want to append an error message to our error buffer. So self.errors append, you must enter a first name. And essentially what gets appended is the message that the user will see. Same thing with the last name. Okay, is the last name blank? If it is blank, we want to append, you must enter a last name. If self.data email equals blank, append, you must enter an email. And elif this a, the @ sign, right, is not found in the email, right, self.errors append, invalid email. If it's an email, it has to have an @ sign. That's a very simple. Obviously there's much more complicated ways to evaluate email addresses, but this is just a very simple version of this. Okay, so all these errors we want to check, and this function you can actually see will return true or return false if there are error messages. So we check the len of errors. So if any errors exist, we want to check the len, it will return false, and otherwise it will return true, which means this validated properly. So if verify new, right, is true, then there's no errors. If verify new is false, then there are errors. We can go to self.errors to find out what those errors are. Okay, and so I'm going to save this, and then I'm going to verify. So I'll kind of demonstrate all of that. All right, so let's try our first kind of unit test here, and let's say if u.data verify new. Remember, this is going to result in a true false result return value. So we don't have to say any condition here. We can just say if verify new. I'm going to print the error buffer. So I'm going to say print u.errors, and that will print a list of errors. Oh, actually, no, sorry. There won't be any errors in this case, so it'll print verify OK. Else, I want to print the errors. Okay, so that's that error list. And remember, we defined that here. We created a blank list for it, and then we populate that list in the verify function. And this way, the object actually it carries around with it all the errors that have to do with its own data. It carries around its own data, plus it also carries around the error messages for that data. And this is nice, right? In object-oriented programming, we call this encapsulation. We're encapsulating the data and the functionality inside of one single object. All right, so let's go back to our unit tests. I'm going to go here, and I'm going to let's get rid of that. And what I'm going to do is, in this case, right, so remember we're appending a new row. So let's create a new user here. And this will, when we do this, it will create a completely new user. So this won't append 2 rows. It will just create, there'll be 1 row there. Okay. And let's create an error message. Let's do something that creates an error. So I'm going to make the first name blank, and let's make the email address invalid. Okay, save that. All right. List object has no attribute verify new. Okay, why is that? Okay, right, because I called data.verify new. Whoops. Okay, so verify new is a method of the user object. It's not part of the list. So, all right, so we can see that our first unit test, verify OK, and then the second unit test came back with errors, right? You must enter a first name, invalid email. Okay? So there's our verification function at work, right? And so this is really nice because all the functionality, how we verify a particular user, all happens here, right? And that allows us to take that little bit of code, that little kind of special functionality that only this function knows how to do, and tuck it away in the object so we don't have to worry about it kind of floating around in our application. And now, anytime we want to kind of verify a user, right, we just have to do this. Okay? And we can make decisions whether or not a user is verified. We can also get those errors and we can print them to a user. I'm just printing the list here, but obviously, right, we could print this list in a kind of nice format. We could print this list next to the field names, right? So that each field was appropriately pointed to. Okay, so so that's kind of the general unit test for our verify new function. Okay. All right, so that's all I'm going to show you for that part. Again, next week we're going to start adding in database connectivity, but I want to just kind of get our object framework up and running.